So I want to give a brief overview of the lecture we had on payment systems and robustness. And the basic question here is what happens if you make a small mistake when you create a payment system? And in order to discuss this, let's start by saying, okay, let's say we want two things from the payment system. We want high volume of something, and we're going to call this volume. We could call that X, for example. And we also want quality. We could call that Y. So if you're setting up a payment system, you want the system to produce high volume, high quality. Let's say it's impossible to observe quality, but you could observe volume is fine. So when you create a payment system, you're going to create a payment system, say total revenue is equal to some kind of fixed sum, A, plus B times the volume. That's the bonus you get. If you produce extra volume, you get more money. Because you can't put quality into this payment system right now because we assume that it's unobserved. So you're going to do it like this. Total revenue is going to be equal to a fixed sum plus a bonus based on how much you produce. Now, if you're the government and designing this payment system, the policy question you're facing is how big should A be here compared to B? In order to answer that, you have to think how will the people behave when they face this incentive system, the total revenue here. You created a payment system. And people, they have incomes like that, but they will also have costs. So you will have to have a budget condition here. And let's say it costs 1 unit to produce X and 1 unit to produce Y. So if total revenue has to be equal to total cost, that means the budget constraint is going to be, so total revenue is A plus BX. That's how much you're going to have an income. And the cost is going to be X plus Y simply because we assume that the price of X is 1 and the price of Y is 1. So this is how the hospital, for example, that's what they're facing. They're facing the fact that they have to balance the budget, and this is the income and this is the cost. And before you set the values of A and B, you will have to think how will the hospital behave when you set different values for A and B. Now, before you go on, you should notice there's one important property based on this. And the two ways of actually finding this property. One is just, let's say you're on the board of a hospital and you're facing a $100 million deficit. What are you going to do? Are you going to cut volume or are you going to cut quality? Well, if you cut volume in this, when you have this payment system, then you know you're going to lose some income as well. So even if you cut $100 million, it's not going to be enough to balance the budget because, okay, you cut cost by $100 million, but also income will go down, so you still have a deficit. But if you cut quality, because the quality is not incentivized in the payment system, you could cut quality by $100 million and you'll be back in balance. So this incentive system here, it obviously incentivizes people to focus on the things that are in the incentive system. Now, the important thing is to notice how strong is that incentive. It's easy to see that it is there, but how strong is it? Now, one way of finding that out is, as I said, imagine that you have to cut $100 million. And if the bonus payment is, say that is 0.5, B is equal to 0.5. If B is equal to 0.5 and you start cutting $100 million, and after you've done that, then you still have $50 million deficit because you'll lose income unless you have slack in the organization. So you cut 50 again, but you still have a deficit then because after cutting 50 you're still going to lose some income, so you had 25 in deficit. Cutting 25 you had 12.5, and you see you go on like that, and then you discover exactly how much you have to cut when B is equal to 0.5. It turns out you're going to end up with having to cost something like $200 million. The deficit was 100, but you have to cut 200 from volume-based activities in order to get back to balance, because when you're cutting there, you're also cutting your income. So basically it costs twice as much to cut in volume as it costs to cut in quality then. You have to make a cut that is twice as large. But the size of the cut will depend on the value of B. And if you actually look closer at this here, you have a geometric series, and you can actually work out the value or the sum of this depending on different values of B. And we know from high school, if you remember back, that is going to be 1 over 1 minus b. That's the sum is going to be that. Okay, so now we know basically the cost of cutting in one compared to the cost of cutting in the other, depending on different values of b. How strongly we incentivize volume, how strong the bonus is based on volume. A high value of b means that the bonus is important in the payment system. B could be 0, then you only have a fixed payment system. So the higher the bonus payment is, the more costly it will be to produce quality compared to volume. But not only the more costly it will be, it turns out that this here, it has the following properties. Let's say b is on this axis, and this is the cost of cutting in volume compared to quality here. Cost, it's going to be like this. So it's going to grow exponentially, which means that, let's say 0.5 was here. Okay. At some point, let's say the bonus payment is 90% of the total payment. Then it's really, really expensive to cut in volume compared to quality. It grows very fast. And that's important to notice, and that's maybe a little bit surprising. We're used to thinking a little bit more is going to cause a little bit more problem or a little bit higher incentive. But it turns out that a higher value of B could create a big change in the cost of volume compared to quality. So what does this mean for payment systems? I think you have 4 potential conclusions here. I want to note first of all that this is not carved in stone. This is not necessarily, you could improve on this model, but let's try 4 propositions here. First, when you design a payment system like this, you will be more afraid of mistakes in this direction than in this direction. Why? Because a mistake in this direction can easily cause a big difference to the incentive for the agent in terms of how much they're going to produce. As a mistake in this direction will still make the agent behave differently than you want, but the difference will not be as big, because up here the mistake will grow very fast. Down here it doesn't grow that fast. So basically the loss of setting the wrong value for B, the loss of setting a wrong value will be smaller when you have a small error to the left of the optimal value than when the loss you will have than if you put a B that is too high compared to optimal value. So in short, you will be more afraid of creating a big bonus than you are of not having enough of a bonus in the system. Now the second proposition I want to make is, let's compare the situation with when you have full information and no uncertainty to the situation where you have uncertainty. And I will argue that the optimal value you should choose, given that you have full information, will be bigger than the optimal value when you have uncertainty. Why? Well, again, it's this here. When you're afraid, when you have uncertainty, you will be afraid of making mistakes. And it's worse to make mistakes to the right of the optimal value than to the left of the optimal value. And if you then create a loss function, basically, the loss function will look something like this. Let's say this is the optimal value, be here. That's the best you could get. It'll look something like this. There, and then it'll go up there. So since it goes up very fast here, then you will be more afraid of suddenly ending up here. So in order to ensure yourself, you're going to go in this direction, be there instead. Now the third conclusion you may draw from this is that if there's a lot of uncertainty, then also your value, the optimal value of the bonus will go down. So a lot of uncertainty is increased, then the optimal value of B will go down. Why? It's the same logic as here. Then if the uncertainty is large, you'll be really afraid that you may be in this area where you have where a small mistake will have big effects on the adjustments. So you'll be really afraid of ending up here when you have lots of uncertainty. And you will assure yourself by going to the left again. The fourth and final conclusion is, if the government and the hospitals or the people working in the hospital, if they disagree a lot in terms of what the balance should be between volume and quality. Let's say the government want to put a lot of emphasis on volume, but the doctors working in the hospital, they want to focus on quality instead. And they don't care that much about the waiting list because they only see the patients in front of them. So if there's a lot of disagreement, then you will have to have a strong bonus incentive in order to make the doctors actually focus on volume. But when you have a strong incentive or make the bonus payment high, then you will also be likely to be in this area where you can make mistakes, where mistakes have big consequences. So if you have if you have big disagreements, the larger the disagreement is, the larger the potential for distortions will be. By that I mean, when you are in this area, when you create high bonuses, you will also have a high probability of actually making mistakes that are very costly. Because when you have high bonuses, small mistakes will be very costly, because small mistakes, small changes in the bonus system will actually make the people behaving in that system change their behavior quite dramatically. So small mistakes in this area will cause big differences. And when they disagree a lot, you have to give them big bonuses. But then again, that will increase the probability that the bonus will be wrong, and you will have distortions compared to what you wanted. So these were four arguments, just building on this basic thing that when you have a financial system, a payment system that actually pays you a fixed salary and a bonus, but only one of the things that you want the agent to produce will be in the payment system, for example volume but not quality. If you have a system like that, there's an incentive to focus on volume, and that incentive is actually very strong and it's non-linear, and that's actually causing these four different things here. And that's the basic things I want to get across. Thanks.